Let me ask you something. If I told you that you could sleep 8 hours, eat a clean diet, and exercise 5 days a week, and still feel exhausted, foggy, and strangely off, what would you say is wrong? Because here's the thing, most people would look at that list and say, nothing, that's the whole list. Sleep, food, movement. Those are the 3 pillars everyone talks about. Every health video, every wellness account, every doctor's office poster, sleep well, eat well, move more. And they're not wrong. Those 3 things matter enormously. But what if I told you there's a 4th pillar? One that almost nobody talks about? One that your body is measuring every single second of every single day, and one that when it's missing quietly, undermines all 3 of the others? I'm going to be honest with you right from the start. This is not going to be one of those videos where someone tells you to get more fresh air and calls it a health protocol. I find that kind of content frustrating because the actual biology of this 4th pillar is so much more interesting than vague advice about going outside. What I want to do today is show you what is literally happening inside your brain and your cells in response to something you interact with every waking moment without ever thinking about it. And by the end, the missing piece is going to feel completely obvious to you. Not because I said so, but because you'll understand why. And when you know the reason behind the rule, you never forget the rule. So let's build it from the ground up. The 4th pillar is light, not vitamin D, not sunshine as a vague mood booster, light itself as biological information, the timing of it, the intensity of it, the color of it, and what your body does with all of that data. Here's the foundation everything else sits on. Every cell in your body contains a molecular clock. And this is not a metaphor. There are actual clock genes. Clock, BMAL1, PR1, PR2, CRY1, that regulate the timing of thousands of processes at the cellular level. This discovery was considered important enough that the 2017 Nobel Prize in Physiology or Medicine was awarded to Jeffrey Hall, Michael Rosbash, and Michael Young for working out the molecular machinery of these circadian clocks. This is Nobel Prize level science, and it runs inside you right now. But here's the part that most people have never heard explained properly. These cellular clocks don't keep perfect time on their own. Left completely alone, no light cues at all, your internal clock drifts. It runs on a cycle slightly longer than 24 hours, which means every single day, your body needs a calibration signal. Something has to come in from the outside world and tell trillions of cellular clocks, this is morning, start the day program now. And that signal is light. Specifically, light entering your eyes. Now, I want to stop here because this next part genuinely changed how I think about my own body. In the early 2000s, researchers discovered a completely separate light-sensing system in your eye that has nothing to do with vision. You've got your rods and cones. Those are for seeing shapes and colors. But there is a 3rd class of cells in your retina called intrinsically photosensitive retinal ganglion cells. They contain a photopigment called melanopsin, and they don't help you see anything. Their entire job is to measure the brightness and the blue wavelength content of the light in your environment and report that directly to a tiny structure in your brain called the suprachiasmatic nucleus, the master clock. The conductor of the entire circadian orchestra. Think about what that means. Your eyes are not just cameras. They are dosimeters. They are constantly measuring light dose and using it to set the timing of your hormones, your body temperature, your digestion, your alertness, and your sleep. And here's where modern life enters the story. Because the 2 light environments your biology was built around, bright outdoor days and genuinely dark nights, have essentially disappeared. Let me give you the numbers, because the numbers are startling. Outdoor daylight on an overcast day delivers somewhere around 1,000 to 10,000 lux. A sunny day can hit 50,000 to 100,000 lux. Typical indoor office or home lighting, around 100 to 500 lux. So when you spend your morning indoors, which most of us do, your master clock is receiving a signal that is 10 to 100 times weaker than the signal it evolved to calibrate on. From your brain's perspective, you spent the whole morning in twilight. And then, at night, we do the exact opposite. We flood our eyes with bright artificial light and screens at the precise hours when the brain is supposed to receive darkness. So, the day signal is too weak, and the night signal is too strong. The contrast between day and night, which is the entire basis of the calibration system, has collapsed. This has a name. It's called circadian misalignment. And the research on what it does is not subtle. Let me start with sleep, because this is where it lands first. When those melanopsin cells receive bright morning light, they don't just wake you up. They start a timer. That morning light signal anchors the release of melatonin roughly 12 to 14 hours later. Melatonin, as you probably know, is the hormone that initiates sleep. So the timing of your sleep tonight is being set by the light you got or didn't get this morning. Not by how tired you feel, not by your bedtime routine, by the morning light signal. And there's a study I want you to know about because it makes this concrete. Researchers, led by Mohammed Boubekri and Phyllis Z at Northwestern University, studied office workers and compared those who worked near windows with those who worked in windowless spaces. The workers with window daylight exposure received 173% more white light during work hours, and they slept an average of 46 minutes more per night. Not from a supplement, not from an app, just from light exposure during the day. Same jobs, same buildings, different light. 46 minutes of additional sleep every night, as a downstream consequence of a daytime input. Now, let's talk about the morning hormone side, because this connects to something you may have heard me discuss before, the cortisol awakening response. In the 30 to 45 minutes after you wake, your cortisol rises sharply, by somewhere between 38 and 75%. This is healthy. This is essential. It mobilizes energy, sharpens alertness, prepares your immune system. But here's what matters for today's topic. Light is one of the primary amplifiers and regulators of that response. Bright morning light strengthens and properly times the cortisol peak, so it does its job in the morning and then declines through the day the way it's supposed to. Without that light anchor, the rhythm flattens, and smear's cortisol shows up late, hangs around into the evening, and interferes with the melatonin rise you need at night. One missing signal in the morning, and both ends of your hormonal day degrade. And then there's mood. And I want to handle this one carefully and factually, because the data is genuinely striking. Large-scale analyses of daylight exposure have found consistent associations between time spent in outdoor light and mood outcomes, and light at night tells the other half of the story. Studies of artificial light at night have linked higher nighttime light exposure to suppressed melatonin, disrupted sleep architecture, and elevated risk markers for cardiovascular and metabolic problems. Reviews of the light at night literature have connected chronic exposure to circadian phase disruption and cardiometabolic strain. Your brain and your arteries are both reading your light environment around the clock. Now, the strongest natural experiment we have for all of this is shift work. And I say this with real respect for the millions of people who do it. Shift workers are, biologically speaking, living in permanent circadian misalignment, active under artificial light when the body expects darkness, sleeping when the body expects day. And the research on chronic shift work shows exactly what you'd predict if light timing were a true pillar of health: disrupted melatonin and cortisol rhythms, deteriorated cognitive performance under misalignment, measurable changes in gut microbial metabolites, and elevated cardiometabolic risk. This is what happens when the fourth pillar is chronically missing. Shift work is the extreme version, but a dim indoor morning, followed by a bright screen at midnight, is the same mistake, in miniature, repeated 365 days a year. So now the answer to the title's question should be assembling itself. The fourth missing piece is not a supplement. It's not a cold plunge. It's not a product at all. It is the daily light-dark cycle, and specifically, the fact that your routine is probably delivering it backwards. Too little real light in the first half of the day. Too much artificial light in the last half. Now let me tell you specifically, and I mean specifically, what working with this system actually looks like. First, get outdoor light into your eyes within the first hour after waking. Neuroscience communicators like Andrew Huberman at Stanford have emphasized this repeatedly, and the underlying biology supports it. Low-angle morning sunlight is exactly the signal the melanopsin system is most responsive to. On a clear day, 5 to 10 minutes may be enough. On an overcast day, aim for 20 to 30. And an important detail through a window doesn't count the way you'd think. Glass filters and reduces the intensity dramatically, and you end up back in that twilight zone. Step outside. Balcony, porch, a short walk. You don't stare at the sun, ever. You just let the daylight environment reach your eyes while you do something you'd do anyway. Second, make your days brighter in general. If you work indoors, sit near a window. If you can remember those 46 minutes of sleep, if your environment is dim, a bright light source near your workspace in the morning hours is a reasonable stand-in. The goal is contrast. Your master clock is a contrast detector. It reads the difference between day and night. So, give it a real day. Third, defend your nights. In the last 1 to 2 hours before bed, dim the environment. Overhead lights are the worst offenders because the melanopsin cells are most sensitive to light coming from above. That's where the sky is. Lower the lights, use lamps at low positions, reduce screen brightness, and let the darkness signal actually arrive. Melatonin onset is exquisitely light-sensitive. Even modest room light in the evening can push it back and shrink it. That's the whole protocol. Morning light, bright days, dim nights. Free, no equipment, and it takes less time than brewing coffee. Let me close with the bigger picture, because I think it's worth saying directly. We spend enormous effort optimizing the 3 pillars everyone can see. Tracking sleep, counting protein, logging workouts, and all of that is good, but those 3 systems don't float freely. They hang from the 4th one. Sleep timing is set by light. The hormones that manage your energy and your metabolism are timed by light. Even your digestive organs run on clocks that calibrate to the same signal. When the light-dark rhythm is right, the other 3 pillars work better with no extra effort. When it's wrong, you're pushing a boulder uphill and calling it a discipline problem. And here's the part I genuinely love about this biology. The system is not holding a grudge. Your circadian machinery responds to the signal you give it now. Studies of circadian interventions consistently show that rhythms begin re-anchoring within days of consistent light timing. Not months, days. Your biology is not asking for perfection. It's asking for a clear signal. Bright morning, dark night repeated. So, tomorrow morning, before the phone, before the email, before the feed, step outside. Let the oldest calibration signal on Earth do the job it has been doing for your species for hundreds of thousands of years. The 4th pillar was never missing. It was just waiting outside the door. If this video helped you see your daily routine a little differently, make sure to subscribe to the channel and leave a comment telling me which part of this surprised you most. Thanks for watching, and I'll see you in the next video.